Okay. So yesterday I was looking at how to modularize large GraphQL servers because especially when we're designing an e-commerce schema where deeply nested objects are very common in e-commerce or in any sorry or in any application with some technical depth, use GraphQL makes sense for that. And it's actually amazing how easy it is to query really complex data structures to get the data that you want. So our API is now organized in types and fields rather than endpoints. So because as your GraphQL servers gets larger, it is important to know how can we make that much more maintainable. So right now I'm going to open here Visual Studio Code and to see how to see the README and the paragraph I wrote here, especially here, right? Because so yeah, it's basically this, right? This section. So as our project gets larger, so instead of keep everything in one file, as our server grew, especially when we're designing this e-commerce schema and where we define is the GraphQL capability for our small e-commerce. So as our project gets larger, uh, we ask ourselves, how can we break down the schema into multiple files, structure projects based on functionality, and organize our servers when we need to add more complex data or when we need to add more complex logic to fetch our data. So GraphQL tools greatly help us here. It's an open source of a set of utility that simplify how we make GraphQL server, and it is used under the hood by Apollo GraphQL framework, but it's available as a standalone package. So since Apollo is a service company of GraphQL, all right, it's not a good idea to fully commit on their server, especially if you plan for flexibility reasons. Whether there are feature or platform, if you want to shift to different platform, or for legal purpose. Now, because of that, okay, a modularized large GraphQL project schema, okay. So here we're going to structure it like in a scale, like in a large scale project by feature. Again, this comes is here. Yep, the complete course Node.js development in 2023. Adam Osikowski and Andrea Aoi. That's right. Uh, I just want to sign in. Okay, there is a bunch of course here, but right now I'm focusing on Node. All right, and thanks to Ryan Dow for creating this tool and not focusing on the polynomic topography. Okay, so yeah, modularizing large GraphQL project schema. This is the video that I saw yesterday, and especially here. Okay, so here we're going to structure it like in a large scale project. Key aspect here, structure of projects like in a large scale app. by features. So we can use it. So we can use is what GraphQL. We can use this GraphQL. Okay. So we can use GraphQL tools, and the way it works is that we can import different tools as we need it. So for example, yesterday we import is the schema. So each tool lives in a GraphQL package under GraphQL tool. So yesterday we import is a GraphQL tool schema, and to replace the build schema with our next executable schema, where we on the type def property we pass is an array of type definition and a string for that. And something you will see in large project is define a GraphQL schema. So for example, like this. So because yesterday we were having, so yesterday we have all of our products or orders schema defined in the entry point, the server here, like here, and here the schema text. So in our case, we create is each file for our schema types. So okay, so we create is the product and the order, and the great thing of this is by using this the GraphQL tools schema, it by default merge these objects, so our GraphQL server exposed is the products and orders here. Remember that query is the entry point for a GraphQL server, and to make HTTP or to get the data or request the data, here we use an HTTP host, and we pass the necessary data to get the data that we want. So now that we organize our files separately, how can we import all of our files in our schema? In our schema. Again, since GraphQL tools, the way it works is that we can import different tools as we need it. So each tool lives in the GraphQL package under the GraphQL tool, under the add GraphQL tool. Okay, so here we make use of a schema, and if we want to load or import all of our files into our schema, we use this particular function. So the function we import here using is a require this CommonJS module resolution system, and we get is the load file sync, will allow us to load files following a particular pattern or the log, and using this function. Since we need is to pass is where all of our files will live, and for the sake of example, we use here is the this notation where you pass is a ***/star dot GraphQL. So you tell it to load file sync is, hey, look for all of the different look in our project for all the .GraphQL files extensions, right? And load file sync and pass it to the make executable schema function to load the type array. This is a useful approach since as long as there are valid schema and there is no name conflict. Exactly what we did yesterday. So here we define is this particular pattern for the file load sync, and because we want to pass is the current folder structure or the current path, we use is the private property their name, that tells you where is this, where is the root, where is the path of this file when you invoke this. Okay, and make use of the pass join to actually pass that to the log file sync. And then once you get all of this schema, remember, as long as they are defined, as long as they're good defined, and there is no name conflict, this is a good approach to load your files here. So what you did is, after you make this, you're gonna wait for all of those files, or you're going to iterate through all the entire project structure, looking for the GraphQL, all right? And once you get all of that as a text, you're going to pass this as type arrays. And since make the executable schema works with the GraphQL HTTP server, there is no need to add anything else behind the scenes. And this, in fact, works pretty well. So npm start. Okay, because for some reason, anytime use version 14, okay, npm, that's right, no version, we got is this, okay, and when we type npm start, our GraphQL is up and running. So we navigate here to the localhost 3000 GraphQL route, and we get this. So when we run the query, that's it. That's right. So we get is the product by description, and we have only 2. Where you can look at this data in here, where we are importing is as placeholder for product and orders. Okay, products and orders, and this is the data that is showing here, specifically for the description for one product and for the second product. And as you can see, it's pretty easy to query really complex data structure and ask the data that you want. Simple, pretty straightforward. Now, I'm going to look at this GraphQL tools update. So heads up, in the latest version of GraphQL tools, the load file sync function has been updated to make it a bit easy to use different file extension for the GraphQL schema. We should now replace the load file sync with load file sync. So instead of using is the path.join, which is something that are quite familiar, especially when you want to look for all of the different files, under a particular folder. Here we're making use of this on load file here. It now says, well, you're going to pass is this string stars of all files. So you're going to indicate, hey, I just want to look for all the folders in as an option here, which is the extension. Okay, I just want this to look is the GraphQL file. There is a lot of abstraction here, but underneath the hood, it's actually doing the same thing here. This is a more descriptive and more like a software developer should know when it comes to identify where is a particular file where we should go to find files and things like that, right? So this, in theory, supposed to work just fine. When we navigate here, when we refresh, when we run the query, that's right. The only thing that changed is how do we passing is the options for the low sync, for the low file sync coming from GraphQL tools low file. Okay, that's great. Other possible extensions include TS, GS, GQL, and GraphQL's. Alright, see you in the next video. And again, this is particular to this tool. And now we're looking is at resolvers.
Welcome back. Every large-scale GraphQL server has two main components, the schemas and the resolvers. We know all about these schemas, but...
Okay, I'm going to make a pause here because here... Here we're talking is about resolvers. Okay, so this is resolvers. So resolvers, and you mentioned something important to me.
Every large-scale GraphQL server has two main components.
Every large-scale GraphQL server has two components. Interesting.
Welcome back. Every large-scale GraphQL server has two main components.
We have two main components.
The schemas and the resolvers. We know all about these schemas, but what on earth?
The schemas and the resolvers.
Is a resolver? The answer lies in what happens when we make a query. GraphQL always first determines if the query is valid by looking at our schemas, and then it executes that query. When executing a query, the value of each field is determined by calling a function called a resolver. When a field is included in our query,
Okay.
lies in what happens when we make a query. The schemas and the resolvers. We know all about these schemas, but what on earth is a resolver? The answer lies in what happens when we make a query.
Okay. So what a resolver, or what are resolvers? The answer rely on the query.
What on earth is a resolver? The answer lies in what happens when we make a query.
Okay. The answer relies on what happened when we make a query. An interesting question. Exactly. What happened when we make a query?
GraphQL always first determines if the query is valid by...
This is when you look at the GraphQL specification here, the graph spec here, on the type system, where it says the GraphQL type system is so describes the GraphQL capability and is used to determine if a request operation is valid. The type of the resulting object or the type of the response result and describe the input type of variables to determine if their values provided at request time are valid. So this is much like at what happened or what is describing here.
Looking at our schemas, and then it executes that query. If the query lies in what happens when we make a query. GraphQL always first determines if the query is valid.
We're going to use a GraphQL always determines if a GraphQL is valid
by looking at our schemas.
Exactly. By looking at our schemas.
And then it executes that query.
And then it executes that query.
When executing a query, the value of each field
when executing that query, the value of each field
is determined by calling a function called a result.
The value of each field is determined by a function called resolver.
When a field is included in our query, the corresponding resolver is called to provide the value for that field. When the server has called all the resolver functions found in the query, it then wraps all those values up and sends them back to the front end,
Oh, come on, man. No? Yes. Come on. No. Oh, it's fucking no. No. Yeah. No. Okay.
to the client that asked for the data in the first place. So why do we need these resolver functions anyway? What problem do they solve? So far, in our GraphQL code, we've been using these root values to determine what data comes back from our API. But these root values point to our models that contain hard-coded data, like our orders model right here, which isn't very realistic. When we need to do an API call, a database query, or some other logic to get the data for one of our fields, one of these fields from our GraphQL schema, instead of using these hard-coded root values, we use functions that we call resolvers. GraphQL calls all the required resolvers, we fetch the data that we need in our resolver function, and the data gets sent back to our clients. To update our code to use resolvers, we can use our makeExecutable schema function, which, in addition to our type definitions, which contains our schemas, we can also pass in a resolvers property. This contains an object with all of our resolver functions. For our basic queries, where we're fetching some data from the server, we add our resolver functions under this query property, which includes functions that match all of the root values of our schema. So products, which contains some function, we'll use this anonymous function syntax, and orders, which has its own resolver function. Each of these resolvers takes in some arguments with data that GraphQL makes available in case we need it. There's the parent, the args, the context, and info. When we're passing in some root values, the parent starts out as being that root object. So to return the product, when the product's resolver is called, we could just say return parent dot product, and the value from the root will be returned when GraphQL calls this product resolver. We can log that our resolver is actually being called, so we're getting the product, and now we'll know that this function is actually being used. All right, what about these other arguments? Well, args is used when we have parameterized queries. For example, when we want to filter our products based on some condition. We'll learn all about this in an upcoming video. Now, the context is useful for data that's shared across all our different resolvers. For example, if we want to pass down authentication data about which user is logged in to every one of our resolvers. And info contains some information about the current state of our operation. Because many of these arguments are only used in advanced cases, we'll often see them excluded from our resolvers. For our product, we only really care about the parent. The rest of the data is completely optional. Now, for orders, we could do much the same. We pass in the parent and just return parent.orders. And we can log that we are indeed getting those orders from this function. So getting orders. Now, if we run our server, npm start, we can go into GraphQL and execute a query. We're getting the same data as before, but it's now coming back through our resolvers. All right. So we're doing pretty much the same thing we were doing before, just with this added layer on top. But the beauty of this is that our resolvers can now make API calls or asynchronous database operations and combine different data or filter it. And that's the data that GraphQL will send back to our users. As a simple example, let's make our product resolver asynchronous. So it returned this promise, which we can create using our promise.resolve function that creates a new promise that immediately resolves to our product's data. GraphQL will now wait for this promise to resolve before sending the data back to the user. We could even make our resolver function async and use the await syntax instead, and say that the value from this promise goes into a product's constant, which we then return back. Our server will still work exactly the same. We can restart our server, and back in GraphQL, executing our query now involves waiting for some asynchronous events. This is powerful stuff. Our resolvers can now do complex asynchronous operations to fetch whatever data we could possibly need. Now, you might be thinking, wouldn't it be nice to split up our resolvers, just like we did with our schemas, so that we could have our products resolvers next to our product schema and our product model, and likewise for our orders, instead of having everything all in one giant resolvers object. After all, this approach here would get quite messy for more complex operations, or if we supported many more different types of queries. Well, those are some great points. Let's find out how to structure our resolvers and make things a little bit more modular in large GraphQL projects. I'll see you in the next one.
And with that, I'm going to conclude this section and this recording. Until next time.